perpendicular distance. This total is 80, this is 40. So this perpendicular distance will come 40. So into 40. Now from here you can get 200 will be equal to 10 plus 40 m. From here if you solve, your m will be coming as 190 by 40. That will come finally 19 by 4, or you can say 4.75 kg. Is it okay? Yeah, correct. No problem. Very good. Yeah. Is it okay? Can I be 100% sure if tomorrow question will come, balancing of the meter scale, everyone will be able to get? Everyone will be able to get. Can I be 100% sure? एक बार बोलो भाई, स्वर्गा. First step, represent the mass of meter scale in the diagram. This is the mistake happens by the student. They forget to represent. They simply balance only one mass hanging this side, another mass hanging that side. They only balance that. No. Mass of the meter scale will be also coming, will be giving you torque. Yeah. Not in the NEET 2023. This question came in the NEET 2021. This question came in section B in NEET 2021. But not a tough question, easy question. You can do all this type of question. Yeah. Units are not necessary. Both sides centimeters are there now. Yeah, both sides centimeter are there. So centimeter will get cancelled. So that's why we are not converting centimeter into meter. Some people are saying, sir, you are taking 20 centimeter because centimeter. That's why no need to convert into meter. Directly you can use that centimeter. Yeah. I'm giving you time of 2 seconds. See this question again. Then do the question of the NEET 2021. Now we will move further. One more situation we will talk. Is it okay? Done? Once completed, you can say done, sir. Then we will talk about one more question. Syam, I am saying to say done, sir. You are saying okay, sir. You have to say done, sir. Done also you can say, no problem. Yeah. Remanth, if you will do, then it will become lengthy. You can do for every point. Yeah, okay, no problem. Yeah. Now some questions are asked like this also. Dhyan do, be focused. Yeah, okay, no problem. Dhyan do, be focused. One more situation. Yeah, okay, no problem. Yeah, okay. Achha, here how many supports are present for the system? You tell me here for meter scale, how many support I have put? How many support I have put for the meter scale? How many support is present for the meter scale? One support, but sometimes you can put two supports also. Some questions are asked like this. They will say one meter scale is there. Right now I am supporting meter scale at one point, but sometimes they can put meter scale at two different supports. So when two supports will be there, you'll write equation for both supports separately in order to get your answer. Dhyan do. When one support is there, you are writing net torque about one support to be 0. If two supports are there, then you have to write equation 2 times for the torque for the both supports separately in order to get your answer. I will give you one question. Again, previous year NEET question, you try to do by yourself. You write, come on. You write a little new type of question. You write, in the given figure, a meter scale is balanced. In the given figure, a meter scale is balanced on two knives. Two knives means two supports are there. Okay, no problem. Yeah. In the given figure, a meter scale is balanced on two knives separated by distance d. Two knives separated by distance d. If weight of the meter scale is W, if weight of meter scale is W, at a distance x from knife A at a distance x from knife A, then find, can you tell me what they will ask you to calculate here? Then find, can you tell me what they will ask you to calculate here? Weight of the knife already, weight of the meter scale already given, no other weight is present. What they will ask you to calculate here? Can you tell me? Then find, socho bhai, what they will ask you to calculate? Then find, then find normal reaction from each knife. This knife will give you some normal reaction Na. This knife will give you some normal reaction Nb. They will ask you find normal reaction from each knife. They will ask you find Na and Nb. This is a little new type of question. Weight is already given W. This was a tough question which came in the NEET, not tough, not tough. If you will not do previously, then it will become tough. Find normal reaction from each knife. Two supports are there. For each support you have to write the equation. When you write equation for support B, torque of NB will become 0. You will get torque of NA. Lakshmi Manasa, very good. Lakshmi Manasa, very good. No problem, no problem. Okay, leave your copy, but do this question. Yeah, I know it's little tough question. Yeah, okay, no problem, no problem. Yeah, Kushma, your answer also somehow correct, no problem. Yeah, this question is not an easy question for a student. We are teacher, we have done this question so many times. That's why for me it is easy. For you, it will be tough. So my advice, after class, do this question again by yourself. First understand here, then again repeat this question by yourself during your study hour. Yeah, okay, no problem, no problem. Some people are saying answer that is correct, no problem, no problem. Dhyan do, dhyan do, dhyan do. Be focused, be focused, be focused. Understand how we will talk. Dhyan do, just here. Yeah, okay, no problem. Yeah, okay. So one thing is clear, one thing is clear. Sir, here two supports are present. If you see one support is at A, another support is at B. That means I have to write equation for both supports. Now Dhyan, just here. Yeah, I will simply say, sir, you are saying this meter scale is in equilibrium. If meter scale is in equilibrium, then torque about B must be equal to 0. Torque about support B. I am writing torque about support B. If your meter scale is in equilibrium, yeah, okay, no problem, yeah. Dhyan do, just see here. I will simply say, sir, if this meter scale is in equilibrium, torque about support B must be 0, or I can also write torque about support A must be also 0. Both supports net torque must be equal to 0. This is what I said to you. Whenever any body is in equilibrium, net torque on the body will be 0 about any point. But don't take any point. You have always select the support. If support is present, always write net torque about support to be 0. I will simply say, sir, one support is B. So net torque about support B must be 0. Another support is A. So net torque about support A must be also 0. Now I will check who will give torque about support B. About B, who will give torque? About support B, who will give torque? You tell me, does MB will give you torque about support B? Does MB will give you torque about support B? You tell me how much torque MB will have about B? How much torque MB will have about B? that torque will be 0. And NB will not give you any torque. Its perpendicular distance is 0. Same thing I told you in the last class also. I will simply say, sir, about B, one torque will come due to NA. So NA into distance D. And that torque must be balanced. NB will not give any torque about B, sir. Who will give torque, sir? NA will give. So NA will give upward torque. And W will give downward torque. So here I will say, so total upward torque must be balanced by total downward torque. Previously we studied left, right. Now we are studying up and down. I will simply say, sir, here about B, NA will give upward torque and W will give downward torque. So I will simply say total upward torque will be equal to total downward torque. And what is total upward torque, sir? NA into R perpendicular. And what is R perpendicular for NA? From support B, what is R perpendicular? R perpendicular will be equal to D. This will be equal to total downward torque. Who will give downward torque, sir? Weight W will give. And what is the perpendicular distance of the weight from support B? What is this perpendicular distance? Batao. Come on, tell me how much is this perpendicular distance? Aur jaldi bata do bhai, please. How much is this perpendicular distance, sir? Are bol do. Are motam is D. This is X. So this will become, sir, D minus X. D minus X. Are baba, how D by 2? Pagal ho gaye ho kya? D minus X. D minus X. So I simply say, sir, total upward torque will be equal to total downward torque. Upward torque, sir, NA into D. Downward torque, sir, W into D minus X. Now from here you will get the value of NA. NA will become W into D minus X by D. This is the value of NA. Now if anyone asks me find the value of NB, again I will say, sir, you want the value of NB now. Second time, sir, NA value came. Someone asked me find the value of NB. I will simply say, sir, total torque about A must be also 0. Now about A, who will give torque? NB will give upward torque, W will give downward torque. So again I will say, total upward torque must be equal to, I am talking for point A, total upward torque must be equal to total downward torque. And total upward torque about A, NA will not give you any torque. About A, NA will not give you any torque. Who will give you? NB. So NB into R perpendicular. What is perpendicular distance? That is D. This will be equal to downward torque. W will give you downward torque. W into what is perpendicular distance from A? That is X. So from here NB will be coming as WX by D. Is it okay? कुछ समझ में आया? कुछ समझ में आया? But you will get idea only when you will do this question again by yourself after the class. जल्दी बोल दो भाई. Okay, Akash. Okay. हाँ. Jonathan, you can solve with the help of center of mass also. No problem. I will tell you that also. No problem, Jesse. Yeah. If you want, someone says, no, sir, I don't want to solve for support. For solving with the help of support, it is more easy. But if you want, you can solve without support also. You can write net torque about center also to be 0. You can simply say, just here one more way is there. You can solve this question like this also. You can solve like this also. Yeah. You will simply say, sir, first thing, this meter scale is in equilibrium. Means it is in translational equilibrium also, rotational equilibrium also. So if you solve for, if you balance the torque about center of mass, then you have to consider both equilibrium. You will simply say, first you will say, sir, NA and NB are acting up. Total upward force is, sir, NA plus NB. And this NA plus NB must be equal to W. This is the first equation which will come with the help of translational equilibrium. When you solve with the help of center, you have to write equilibrium of translation also, equilibrium of rotation also. That's why we did not solve with the help of center. Directly we solve with the help of support. Because from support you will get direct value. If you want to solve with the help of center, then you will simply say, Sir, total up force will be equal to total down force. And this is translational equilibrium. Second equation you write for rotational equilibrium. About center, sir, net torque will be 0. So what is the net torque, sir? One NA will give torque. NA is on the left side, NB is on the right side. So total left side torque, NA into X will be equal to NB into D minus X. For NB from center, we are doing for center of mass. We are calculating same thing with the help of center of mass. For center of mass, if you do NA into X will be equal to NB into D minus X. That is left torque will be equal to right torque. So from here you will get one more relation. NA will be equal to NB into D minus X by X. If you put this NA here and solve, you will get the value of NA, you will get the value of NB. But that is lengthy. Is it okay? One more question required. Final question. Bol do bhai. But do this question again by yourself after class. Then only you will get little idea. Shall I give one more question? Final question from equilibrium. All these are given in NCERT. That's why questions are asked. This year in practical, they have included this part separately. Balancing of a meter scale. Experimental physics, they have included this part. That's why we are talking few questions from here. You can do last question from here. Come on. You write. Find normal reaction from each support. Find normal reaction from each support. Length of the meter scale is 1 meter. Mass of the scale is given 1 kg. Length is given as 100 centimeter. One support is present at 20 centimeter. Another support is present at 90 centimeter. If you are able to do this question, then you have become perfect in this. This is A, this is B. So from here we will get normal reaction NA. From here you will get normal reaction NB. First represent the mass of the meter scale. At which point it will act, that is important. NA into 70 will be equal to, W will be 10. 10 into 40. Shyam correct. Raymond correct, yeah. I will simply say represent the weight of this meter scale. Weight of the meter scale you have to represent in the middle. Yeah. So I'll simply say, sir, weight of the meter scale will be 1 kg means 10 Newton. 1 kg means 10 Newton. And this will be present at 50 centimeter. No problem. Now it's an easy question. Yeah, Manas, it's an easy question. Vedasri correct. Yeah, I will simply say, sir, weight of the meter scale is 1 kg is the mass. So weight will come, sir, 10 Newton. Now, sir, I will write one torque. I will write net torque about B. So about B, NB will not give torque. NA will give, sir, and 10 will give. So how much torque NA will give, sir? So NA into, what is the perpendicular distance? This perpendicular distance will become 70. Because this is 20, this is 90. So this distance will become 90 minus 20. That is 70. This will be balanced by 10 into, what is this perpendicular distance? This perpendicular distance is your 40. Now from here you got the answer. That means Na will come 40 by 7 Newton. Yeah, okay, no problem. Similarly, if anyone asks you NB, then write net torque about A. About A, if you write the torque, about A your torque will become. If anyone asks you NB, about A you have to write the torque. NA will not give you any torque, NB will give you torque. NB into, what is the perpendicular distance? Again it will come 70. That will be equal to, this will be balanced by this 10 Newton torque. So 10 into, what is this perpendicular distance? This perpendicular distance is 30. So into 30. So from here you can get NB also. NB will be coming as 30 by 7. Yeah, very good Gautami. Vagdevi, very good. Yeah, Amrut, very good. And if you add them, you'll find exactly Na plus NB will be equal to weight. If you add Na plus NB, you'll find it will become 40 by 7 plus 30 by 7. That means it will give you 70 by 7. That will give you 10 Newton. Which I was saying you already previously, that Na plus NB will be equal to weight of the meter scale. Yeah, little tough. Yeah, okay, no problem. Yeah, that's why even if they will give you question, they will always give you in section B. 2-3 times they have asked question, but they have always given in section B. Akash is saying now very easy, sir. No problem. Yeah. So these are the questions that we have in equilibrium. I'm giving you time of 5 seconds. See all these situations again. Now we'll move further. We will talk about one more part. Is it okay? समझ में आया? Is it okay? Ardhminda, I'm asking from everyone. कुछ समझ रहे हो? बोल दो भाई. Yeah, Gautami, you got the answer. You understood, no problem. Yeah. Remaining people, कुछ चमका. No, this part is tough. Yeah. No problem. Yeah. Okay. बहुत बढ़िया. Now everyone is saying understood, sir. No problem. But again, after class, practice these questions again. Please. This is my advice. Yeah. Because even after understanding right now, you are thinking, I am explaining to you. I am every time telling you this is R perpendicular. This is how distance will come. But in exam, student get stuck here. Even same question is repeated, you will not be able to do. So again, I am asking you after class, solve these questions again. Again, you solve, then you will get exact idea how to balance the torque. So this is how we have talked about. Now we'll move further. We will talk about angular momentum. You can write angular momentum. Angular momentum. We will start with our next part where we will talk about angular momentum. Yeah, Srikar, that's correct. Yeah. Angular momentum. So you can write it is rotational analog of, just like your linear momentum. The way I said you, in place of mass in rotation we talk about moment of inertia, in place of force in rotation we talk about torque, in the similar manner in place of linear momentum in rotation we talk about angular momentum. So you can write it is rotational analog of, yeah, it is rotational analog of linear momentum. It is rotational analog of linear momentum. It is rotational analog of linear momentum. We'll talk about everything. Yeah, it is rotational analog of linear momentum. Now dhyan do, be focused, important part, tricky part, conceptual part. Questions are asked from here. Always remember the way we studied moment of inertia separately for particle and separately for rigid body. In the similar manner, we study angular momentum separately for particle. then we define angular momentum for rigid body. ध्यान दो, if you remember moment of inertia, first I told you for particle, then I told you for rigid body. In the similar manner, angular momentum first we will study for particle, then we will study for rigid body. So first you can write angular momentum of particle. And how we represent angular momentum? We represent angular momentum by L vector. You can write angular momentum in bracket L vector. That is the representation. You write angular momentum of a particle. So see here how angular momentum of a particle is defined. Yeah, angular momentum of the particle is defined. Just see here. Yeah, okay, no problem. This is the definition of angular momentum. This is the definition of angular momentum. Just see here. Yeah, okay, no problem. Yeah. For example, assume we are having our coordinate system like this. See how we define angular momentum of a particle. Yeah, okay, no problem. Assume we are having our coordinate system like this. Okay, no problem. X-axis, Y-axis. And I am saying, sir, here one particle is there. So let's assume here one particle is there. So this particle is moving. This particle is translating. This particle is moving. That means this particle must have some velocity V and must have some mass M. That means this particle must have some linear momentum. P will be equal to M into V vector. Yeah. So for example, assume one particle is there. Particle of mass M is moving with speed V. So if particle is moving, it will have linear momentum P equal to M into V. Now if anyone asks me, sir, find its angular momentum. The way we calculated torque about axis, in the similar manner, we always calculate angular momentum also about axis. For example, someone asked me, so what is the angular momentum of this particle about origin? So again, we will draw one R vector, just like your torque. Torque was rotational analog of force. Now we are talking about angular momentum, rotational analog of linear momentum. So everything will happen in the similar manner. So if a particle is moving, so linear momentum of the particle is mv. So someone asked me is angular momentum about origin. Again we will draw one R vector. And once you draw R vector, now we will define angular momentum. Angular momentum of this particle will be coming as, the way torque was R vector cross F vector, angular momentum of the particle will come R vector cross P vector. Everything is happening in the similar manner. Torque equal to R cross F. So angular momentum vector will be equal to R vector cross P vector. Now from here you can put the value of P vector. P vector will be M into V vector. Now from here if you want, you can take M outside. If you take M outside, M is scalar. So M into R vector cross V vector. So this is how we write angular momentum of a particle. But we don't require this angular momentum actually. Actually we require value of this angular momentum. So if anyone asks you value of angular momentum of the particle, you can simply write value as M into R cross V. R cross V means, the way we write A cross B is AB sine theta. You can write this as MVR sine theta. This R sine theta is again we call as R perpendicular. So angular momentum of the particle will be coming as MV into R perpendicular. This is the angular momentum of the particle about origin or about a given reference point. Yeah. This is the definition. So L vector will be coming as M into R vector cross V vector. Or value of angular, same thing. For torque also I told you same thing. R vector cross F vector. Here R vector cross P vector. There I told you torque will be R perpendicular into F. Here our angular momentum will be equal to MV into R perpendicular. Is it okay? बोल दो भाई, बोल दो त्वरगा, come on. बोल दो. हैं? Yeah. So So whenever value of angular momentum is asked, you have to use mv into r perpendicular. Now you will be thinking, sir, what is r perpendicular? So the way I said you, perpendicular distance of force. Here r perpendicular means perpendicular distance of linear momentum. So linear momentum of the particle is like this. So this is your r perpendicular. This is your r perpendicular. In this diagram, if you are saying, sir, where is r perpendicular? This is your r perpendicular. Achha, can you tell me what will be direction of this angular momentum of the particle? You know, angular momentum is coming with the help of cross product now. Angular momentum is coming with the help of cross product now. Result of cross product is perpendicular to plane of motion now. And a result of cross product will be perpendicular to the plane made by r vector and v vector now. So that's why we say angular momentum will be always for particle, always perpendicular to plane of its motion, For rigid body, you'll find it will be along axis of rotation. Axial vector, you can say. For rigid body, axis will be there. This is a particle. So that's why we are saying perpendicular to plane of its motion. If the motion is happening in xy plane, then our L vector will be in z plane. Your angular momentum is coming with the help of cross product na. Arey bhool gaye kya? Result of cross product will be perpendicular to plane of the both vectors, plane formed by the both vector. So that's why it will perpendicular to the plane of motion. V vector means motion, r vector means position vector. So position vector and velocity vector will make a plane. Your angular momentum will be perpendicular to that plane. No problem, yeah, okay, no problem, yeah. So come on, tell me, everyone will say, come on, no problem, yeah. You tell me L vector will be equal to m into r vector cross v vector. Everyone has to say. This is the final result that we get for particle. Angular momentum of the particle, L vector will be equal to m into r vector cross v vector. M into r vector cross v vector. Angular momentum of the particle, L vector will be equal to m into r vector cross v vector. If anyone asks me value of angular momentum will be coming as angular momentum value will be coming as mv into r perpendicular. The way torque was r perpendicular into F. In the similar manner, angular momentum will be coming as mv into r perpendicular. How much, Chepandi? mv into r perpendicular. What is the direction of angular momentum? What is the direction of angular momentum of the particle? Jaldi batao, what is the direction? What is the direction of angular momentum of the particle? What is the direction of angular momentum of the particle? Perpendicular to the plane of motion. Perpendicular to the plane. I am telling you direction because this year one question came directly from the direction. What is the direction of angular acceleration they asked. So that's why directions are also important. Yeah. Perpendicular to the plane of motion. Yeah. Perpendicular to the plane of motion. No problem. Yeah. Now dhyan do, be focused. Yeah. Okay. No problem. Yeah. Perpendicular to the plane. Yeah. If it is a rigid body, then you can say along axis. For rigid body, it will be along axis. No problem. Yeah. Okay. No problem. Now, dhyan do, just see here. Yeah. One question has been discussed in NCERT. That question I will give you. You have to tell me. Previously asked in the NEET also. For example, you can write CBI NCERT. Important situation. 2 times already asked in JEE mains and NEET exam. एक बार देख लो. For example, assume this is our XY plane. No problem. This is our XY plane. One particle is moving in XY plane. One particle is moving like this. Mass of the particle is m and particle is moving with constant velocity. Yeah. Okay, no problem. Acha, while particle will be moving, at one instant particle is at point A. Another distant particle is at point B, then particle is at point C. Now you have to tell me at which point particle will have more angular momentum. If I say when particle is at A, its angular momentum is LA. When particle is at B, angular momentum is LB. When particle is at C, angular momentum is LC. You have to tell me where angular momentum of the particle about origin. About origin we are talking about. About origin we are talking about. Yeah. About origin, when particle will have more angular momentum, when particle will have less angular momentum. Amrut, very good. And everywhere constant, same angular momentum will come, because angular momentum is not only decided by mv, it is also decided by r perpendicular. And even if your particle is here, dhyan do, the way you write angular momentum na, you write angular momentum na mv into r perpendicular. And if you see everywhere, right now for example, for C, at point C, particle is here, but if you see its perpendicular distance from origin will be always constant. When your particle is here, maybe your r vector is this, v vector is this, but if you see r perpendicular, again r perpendicular will come this. When particle is here, then also r perpendicular will come this only. When particle is here, then also maybe r vector will change. Maybe your r vector will keep on changing. But r perpendicular will not change. Here r perpendicular will remain constant. Perpendicular distance will remain constant. If perpendicular distance will remain constant, your angular momentum will be constant. We will say, sir, LA will be same as LB, will be same as LC. At everywhere, perpendicular distance is not going to change. Sometimes they also say, if this point, if this distance is A, this distance is B, this distance is C, this distance is D. Tell me what will be value. Tell me exact value of angular momentum. Go on. Shall I write mv into A, or shall I write mv into C, or shall I write mv into D, or shall I write mv into B? Perpendicular distance you have to see. If this pen is crossing in front of me now, maybe right now pen is at more distance, but perpendicular distance will be always constant. Perpendicular distance. I will simply say, sir, you cannot write mv into A. A is not the perpendicular distance. You have to see the perpendicular distance of the particle from origin, and that perpendicular distance is B. So angular momentum will come mv into B, and this angular momentum will be constant. So that's why we say angular momentum of a particle moving with constant velocity is always constant about a given reference point. You can write this statement. This is also a statement which can come in assertion reasoning. You can write, yeah. You can write this statement. If anyone asks you about direction you can find. Motion, what is the direction? What is the direction? Perpendicular to xy plane. Motion is happening in xy plane now. So perpendicular to xy plane means z axis. So it can come plus z or minus z also. But here it will come minus z, yeah. Because r vector, they don't ask this much, yeah. R vector will be like this, v vector. So if you do r cross v, it will come inward. You can simply say z axis, no problem, yeah, okay, yeah, everywhere, yeah, constant means vector constant. You can write this statement. I will repeat this statement, don't worry, yeah, okay. You write, angular momentum of a particle moving with constant velocity. Angular momentum of a particle moving with constant velocity angular momentum of a particle moving with constant velocity will always remain constant about a given reference point. will always remain constant about a given reference point. Can you tell me what is the reason? If this is assertion, what will be the correct reason for this? Angular momentum of a particle moving with constant velocity will always remain constant about a given reference point. If this is assertion, what will be reason for it? What will be reason for it? Tell me the correct reason. What reason you will give for this assertion? Because perpendicular distance remains constant. Maybe distance will change. Maybe particle is going far away from me. Distance of the particle from me is changing. But I don't care about distance, Baba. I can't care about perpendicular distance. So perpendicular distance everywhere will remain same. Because R perpendicular will be constant. Because R perpendicular will be constant. Because R perpendicular will be constant. Do one more question, come on. One particle is there. This particle is moving on a straight line. Y-axis, x-axis. This particle is moving on a straight line. Mass of the particle is m. Velocity of the particle is v. And it is moving on a straight line whose equation is y equal to a. Tell me its angular momentum about origin. When particle is here, tell me its angular momentum about origin. How much angular momentum it will have about origin? When particle reached at this point, yeah. What is its angular momentum about origin? When particle is here. MVA, I will simply first write the, sir, you want value now. So I know, sir, MV into R perpendicular. So M is given, V is given. What is R perpendicular? Sir, this is R, but I don't want R. I want perpendicular distance of R. So I want R perpendicular. So particle is moving on this line, sir. This is the direction of its linear momentum. This is the direction of its velocity. So this is R perpendicular, sir. This is R perpendicular. And this R perpendicular is given. R perpendicular equal to A. So MV into A. MV into A. Not 0, Baba. Acha, what will be angular momentum of this particle about this point? If someone is lying on this line itself, some observer is saying, sir, I am present on the line of motion. Can you tell me, according to this observer, what will be angular momentum? According to him, what will be angular momentum? And now it will be 0. According to this observer, because now R perpendicular will become 0, na Baba. According to this observer, if the observer lies on the line of motion, then according to that observer, angular momentum will be 0. Because now R perpendicular, for him, if the observer lies on the line of motion, R perpendicular will become 0, na Baba. If I am standing here and someone is coming towards me only, so what is its perpendicular distance? He will come to me only. So perpendicular distance is 0 na. So R perpendicular 0 means angular momentum will become 0. About origin, it will not be 0. Achha, tell me about origin, where it will be more. Here more, or when particle is here then more, or here then more. When it is more. About origin, when it will be more. When angular momentum will be more. When particle is here, or here, or here, or here. Everywhere, same value, sir, same value, no change. Because even when you are here, R perpendicular is this. Even if you are here, R perpendicular is this. Even if you are here, R perpendicular is this. Even if you are here, R perpendicular is this. So this angular momentum which you have written is actually a constant value. Yeah, same everywhere. Is it okay? And you can write this point also. You write, if observer lies on the line of motion, 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 then angular momentum with respect to him will be, you have to tell, If observer lies on line of motion, then angular momentum with respect to him will be, you have to tell, will be, the angular momentum with respect to him will be zero, because r perpendicular will become zero, sir. That's why it will be zero. Is it okay? So this is how we have talked about for particle. More situations from here we'll be talking now next class. For today we'll be ending here only. Tata, bye bye. I have to go to other campus. Bye bye bye. Take care. Bye bye.